This video is made by Aya Haggag, Yusra Ibrahim, Nada Shair. Our topic is Hamming codes, and a specific application of Hamming codes is generalized DNA barcode based on Hamming code. Our outline for this video is introduction to what is Hamming code, history of Hamming codes, what is Hamming code in more details, how it can be constructed, its applications, our major application generalized DNA barcode based on Hamming code, and other categories, and we have our results shown. The introduction, a Hamming code is named for R.W. Hamming, Richard Wesley, who created the Hamming codes. It's a linear code for error detection and correction. If we send a message, Hamming codes detect the message and correct it. The subject of error correcting codes was originally derived in response to practical problems in the reliable communication of digitally encoded information. To solve these problems, Hamming codes were made. And there's a numerous application for Hamming codes, but we are discussing one application, as I mentioned before, the DNA barcoding. And errors, why we managed to solve this problem because error arises from a variety of causes, some which are human or equipment failure, lightning, and interference of other frequencies or uh, channels. The history of Hamming codes, it was, as I mentioned before, was created by Richard Wesley Hamming, and he had inventing a code for correcting errors in communication, and the Hamming code was born. At that time, there was error in communication, so he invented this codes, and he was interested in two problems: increasing the distance. We will define what is distance later on, and increasing the code rate as much as possible. And during the 1940s, he developed several encoding schemes that were dramatic improvement on exiting codes.
And now, what is Hamming code? Hamming code is error correcting codes that can detect and correct error that can happen while transmitting or saving data. This can happen by adding bits that called redundant or parity bits. So, how it can be constructed? Well, it's very easy. It can be constructed by adding these parity bits. We will discuss a very simple example, which is 7 by 4 Hamming code. Let's say that we have a message of 0110 and we need to construct a 7 by 4 code. So we are adding a 3 parity bits. Here you can see that we have constructed 3 circles. You can see there is C1, C2, C3, C4, and each circle have a 1 parity bit. We are working on even parity, so the first circle on the right, you can see C1 is 0, C2 is 1, C3 is 1. So there are 2 1s, so there is need to add another one. So the C5, the fifth parity bits will be 0. For the circle on the left, you can see C1 is 0, C2 is 1, C4 is 0. So here we have only 1, so we need to add another 1 to make it even parity. So C7 is 1. On the circle in the bottom, we have C1 is 0, C3 is 1, C4 is 0. So C6 will be 1 to make it even parity. And the resultant code word is 0110011. And the last 3 bits is the parity bits. And here are the parity check equation that can also result the resultant code word. And now the applications and
Applications based on Hamming codes. Error detection and correction applications, 16 by 8 error correcting code, belief propagation in graphs with cycles, and generalized DNA barcode, which we will focus on through our video. Um, Barcoding is the process of using even a short genetic marker in any organism's DNA to identify to which a species it belongs. Usually DNA technicians identify species by color or size or shape, but when it comes to a huge number of samples or a small or tiny damage sample, DNA barcoding helps a lot. But to know how these barcodes are made or how they give DNA samples a tag, they use a powerful method which is called the multiplex deep sequencing. DNA samples can be mixed together and sequenced using modern high technical sequencing machines instead of analyzing every sample alone. But might um, this method or approach requires exact sequencing tags which allow identifying any sampling and assigning it to its real or original barcode. And Aya will talk about the results.
Okay. We know that every DNA molecule consists of 4 amino acids, A, C, G, T, and every sample can be encoded as a binary word. For the researcher, they have used 16 by 11 Hamming code, but for simplicity, we will discuss the result as a 7 by 4 Hamming code. Here in this Excel sheet, we can see the possible combination of 4 by 4 code words. The 4 is the bases with, which are A, C, G, T, and the data is consists of 4 bits, and the power 4 is the bases which are A, C, G, T. Here we can see that this is the data, the column of the data, and here the another column which is the Hamming code that have been constructed. This Excel sheet have been constructed by a Python program, by our a Python code, and this code we give it data and it give us the Hamming code and transmit this Hamming code into a barcode. The A base is 0 in binary, the C is 1, the G is 2, the T is 3. So you can see here that this is 7 zeros, so there is 7 A's, and here you have 2 threes, so 2 A's, 1 0, 1 A, 1 3, 1 T, 2 zeros, 2 A, 1 is C. So this is simply our results. I hope we hope that you have enjoyed our presentation, and thank you.